Says the equation line that passes through the point -9 is perpendicular to the line y equals 3x minus 5. Reminder, Jagger, two lines are perpendicular. What's true about the slope? Opposite reciprocal slope. The slope of this one is 3. The slope of my line, anybody would be -1/3. Any question? I want my line to have a slope of -1/3. I want my line to pass through the point -9/6. In order to find an equation, you need two things. You need a point and you need a slope. Once you have a point and a slope, you can plug it into one slope. Y minus y1 equals m times x minus x1. I'd like to get it where you're so comfortable with that formula, you don't even think about it. You don't even write it down anymore. You just, as you're saying it, like this, y minus y1 equals m times x minus x1. As you're saying it, you just go ahead and write it. Then you clean it up, you've got your equation. Y minus 6 equals -1/3 times x. Negative times a positive will give me a minus. You can put 9 over 1 if you want to, since you're multiplying fractions. Multiply tops, multiply bottom if you do it. Minus 6 moves over and becomes plus 6. Final answer, you get y equals -1/3 x plus 3. That's the line that's perpendicular to y equals 3x minus 5. You can check it. The slope of my original line was 3. The slope of this line is -1/3. They have opposite reciprocal slopes. And not only that, you can plug in the point -9 and for x, and you're going to get 6 for y. You can plug in that point that does well. Okay, says determine whether the two lines represented by these equations are parallel, perpendicular, or neither. Justify your response. Your two lines are y equals 2x plus 3. And in the second one, notice I can't just look at that and get my slope. Help me out, Riley. I need to get y by itself here. What's the first thing you move to get y by itself? Okay, not first. Any term. If you can move a full term over to the other side, move the term over first. So we're moving plus x, and Riley, as I move it over, what does it become? Good. Minus x, and that's positive 6. Still not done. Now I do have to get rid of the 2. Carly, how do I get rid of this 2? Good. And there's nothing here to divide by 2. Anybody know what I can put here in this spot? -1. Divide that by 2. Divide this by 2. You've got to divide everything by 2. So y equals -1/2 x. 6 divided by 2 is 3. There's my 2 equations. Alex, what's the relationship? They're perpendicular. Any questions about why they're perpendicular? One of them has a slope of 2 over 1. The other one's -1/2. Those two lines are perpendicular. Any questions? And by the way, once again, I'm going to post all these notes on my website so you can pull notes off that. Two lines are represented by these equations. Same thing, determine what kind of lines they are. My first line is x plus 2y is 4. My second equation, 4y minus 2x equals 12. I need to get y by itself. I can't look at these and tell what the slope is. Get y by itself. First equation. Colton, what am I going to do to get y by itself? What would you do first? Good. Positive x becomes negative x. And if you want to go ahead and put that 1 with it, you're fixing to have to divide by 2 anyway. Right? I think I did. Put a 1 with it so you'll have something to divide by 2. And math, read for me what I'm going to have after I divide everything by 2. Y equals plus. There's your first equation. Second equation, Hunter, help me get x by itself. What are you going to do first? Good. I now have 4y equals positive 2x plus 12. And Hunter, go ahead and do the next step for me too. Divide everything by 4. I now have y equals 4. Good. Good. And he's thinking ahead. That's 2 4s. 2 divided by 4, so he reduced it. And then plus 3. So anybody, those two lines, are they parallel? They're nearly parallel. Are they perpendicular? They're neither. In order, they're nearly parallel because one of them, they have the same slope except one's positive, one's negative. They have the same slant, that's about all you can say, but one's slanted in a negative way, one's slanted in a positive way. They're not reciprocals. This would have to be negative 1/2 and positive 2/2. So not reciprocals. Those are neither parallel or perpendicular. Move on. Make sure again that we can find equations. In order to find an equation, anytime it says what is the equation, go ahead and write your point slope down. Y minus y1 equals m times x minus x1. And we're going to plug in to that everything that we know. What is the equation of the line? Passes through that point. So we got a point, we got an x1 and y1, but we don't have a slope. We want our line to be parallel to this. Is our slope 2? We can't just look at it. Well, it's going to be 2. But we can't just look at it and say, yeah, the slope's right there. Y has to be by itself. And somebody share with me, what's going to be the easiest way to get y by itself? Should I, think ahead, should I move 2x over? Why don't you move y over? It's going to become positive. If I move y over, and at the same time I'm moving y over, move the 4 back to this side. Does that make sense? So we have 2x, and my equal sign. I'm moving y to the right side, it becomes positive y. I'm moving 4 to the left side, it becomes negative 4. Y equals 2x minus 4. So my slope is 2. Yeah, that actually ends up with a 2. So now we plug in everything we know. Y minus y1. How do we plug all this stuff in, Trace? What's y1? Good. So that'd be y minus negative 11 would be y plus 11 equals what's the other one? Good. Equal or times x minus. So that'd be x plus 6. Everybody good with that? We should be fairly good at finding that. Y plus 11 equals 2x plus 6. Distributive property, multiply everything by 2. Subtract 11 from both sides. You get 2x minus 5. 6 minus 11 is negative 5. So that's going to be parallel to this, and it's going to pass through the point negative and negative. Any questions? We're good? Maybe that's all there is. Oh, this is big. I'm putting more of these on here, so you might want to start this. Which equation represents the perpendicular bisector? And let's graph this and see it. I think that's a graph. There we go. Which equation represents the perpendicular bisector of AB? If A is 8,2 and B is 0,6. So first off, I'm going to graph this so you can see it. A is 8,2. 1, 2, 3, 4, 5, 6, 7, 8, 2. B is 0,6. 1, 2, 3, 4, 5, 6. And I'm looking for the perpendicular bisector of that. In order to be a perpendicular bisector, two things have to be true. Number one, it has to be what? In order to find a perpendicular bisector of this segment, number one, it must be perpendicular. And number two, it has to bisect. It's got to follow both of those. So now, could I draw a perpendicular bisector? Yeah. You find the middle, you draw a line perpendicular to it. Let's go through everything that we know about perpendicular bisectors. Since it's perpendicular, what's going to be true about its slope? Slopes are opposite reciprocals. The slope of this, now that I have a graph, you can count rise and run if you want to. Before I graphed it, you could use the slope formula, y2 minus y1 over x2 minus x1. That's 4 over negative 8, which is negative 1/2. That's the slope of that. And you can check it. Go down 1 over 2, yeah? Down 1 over 2, down 1 over 2, down 1 over 2. Yeah, that's a slope. The slope of any line perpendicular. The perpendicular slope would equal what? So pretty much, if I'm looking for the equation of the perpendicular bisector, my perpendicular bisector has to have a slope of 2, and it must pass through which point? What's that point called? the midpoint. Can you tell where the midpoint is just by looking at it? It's right here, isn't it? If you can't tell, let's talk about how to find midpoints. To find a midpoint, you do what were your x's? Divide by 2. Add the y's, divide by 2, you get 4. Your midpoint's 4, 4. I'll go over 4 up 4. So, guys, all we're doing, we're looking for the line that has a slope of 2. Because our perpendicular bisector has a slope of 2, and it passes through the point 4, 4. Y minus y1 equals m times x minus x. That makes sense. That's going to be your perpendicular bisector. It passed through the midpoint. It had a slope of 2. Clean it up. Y minus 4 equals 2x minus 8. Add 4 to both sides. Y equals 2x. See, add 4, I think that's going to be minus 4. Let's graph that. Just for extra practice, let's graph that perpendicular bisector. Riley, this is in slope-intercept form. To graph it, this minus 4 right here, what is that? Y-intercept. So we go 1, 2, 3, down 4. From that point, Riley, we're going to rise and run how much? Rise 2, run 1. And we continue doing that over and over and over, and look where it passes through. You'll see that passes through where we want it to. And there's my perpendicular bisector. Where's that? Makes sense. Got it across. Any questions? Pass through the middle. It's perpendicular to it. Okay. More of the same. On these, I just a reminder of how to graph. If I ask you to graph y equals negative 3x plus 2, Jagger, what's the first dot I put on here? Do I put the slope first, or do I use the y-intercept first? Always start with your y-intercept. The plus or minus, always put that dot on that first. Okay, to graph it. And then from there, Riley, where do I go? Here's my slope. That tells me where do I go from this y-intercept. I'm going to go down 3 right, there we go. Down 3 right 1. Do it a couple of times. Or I could go up 3, left 1, because that negative you can put on bottom. Could be on top, bottom, both, or maybe on both. Could be on top or bottom. Draw a line. Any question? Another. Y equals 1/2 x minus 5. Carly, have me graph it. Where's my first point? 1, 2, 3, 4, negative 5. From there, Carly, where do I go? Up 1 right 2, up 1 right 2, up 1 right 2. There's y equals negative 1/2 x. Or excuse me, y equals 1/2 x plus 5. Minus 5. That's enough for that. I'll graph this real quick, just to work. Negative 2/3 x plus 4. Your first point is plus 4, 1, 2, 3, 4. From there, that negative can be on top or bottom. So if it's on top, you're going to go down 2, 1, 2, 3 to the right. If you want to put it on bottom, you'll go up 2 and left 1, 2, 3, and then go right hand. Same line. Any questions? 3x minus 5y equals 10. Be able to take an equation and write it in slope-intercept form. Now here, if you want to, you could use some other point. You can find some points that's on this line and do it like that. I highly recommend just put it in slope-intercept form. Alex, I want y by itself. Before I can graph this, before it's in slope-intercept form, y must be by itself. What do I do first with y by itself? So I now have negative 5y equals negative 3x plus 10, and I divide by what? So now I have y equals, I don't know if I can divide that. You can't, can you? 3 divided by, negative 3 divided by negative 5, that's a decimal. Leave it as 3 divided by 5. Well, what's a negative divided by negative? Positive. Dump the negative. And then divide this also by negative 5 and get negative 2. So that's all you're graphing. Minus 2. Rise 3, run 1, 2, 3, 4, 5. Or go down 3 and left. Midpoints? You're the devil, Mr. If you don't remember your formula, and it's on your, should be on your formula sheet. Midpoint formula, x1 plus x2 divided by 2. Add your x's, divide by 2. Add your y's, divide by 2. Easy. Colton, do that for you. Line segment has this endpoint and this endpoint. What are the coordinates of the midpoint? Add your x's, Colton, divide by 2. What do you do? Divide by 2. So negative 1. Add your y's, you get 6 and negative 3 be 3. Anybody divide 3 by 2, you get $3, split it in half, $1.50. Negative 1.5. Find the midpoint, add your x, divide by 2, add your y. Segment AB is the diameter of the circle. The coordinates of A are negative 4, 3. The coordinates of M are 1, 5. What was it? The center of the circle, right? So if you have a diameter, let's talk about that. You got a circle. You have a circle, and you have a diameter of the circle M. You have a diameter of that circle. Diameter has to pass through the middle. It says one of the endpoints, A, is negative 4, 3. It says M is 1, 5. How do you find the other? You could use slope, it's patterns. You add, you find out what adds up to it. How do you get from negative 4 to 1? You add 5 and add 1 again, you get 6. Good. How do you get from 3 to 5? Add 2, so you have 1 here. So the other endpoint 6, 7. That's the easiest way to do it. There's other ways, and you can check yourself. 6 and negative 4 is 2, divide that by 2, you get 1. 3 and 7 is 10, divide that by 2, you get 5. So 6, 7 is the other endpoint. Another. If the endpoint of AB, the endpoints of AB are negative 4, 5, and 2, negative 5, what's the length of AB? What formula are we using here? Distance. Distance equals, and this is on your formula sheet, x2 minus x1 squared plus y2 minus y1 squared. Once again, that's simply Pythagorean theorem. If you want to graph, draw a little triangle, that's Pythagorean theorem. Or you can say, you tell me, how far is it from negative 4 over 2? 6. How far is it from negative 5 to 5? And then just do Pythagorean theorem with 6 and 10. That's a whole lot easier. It's going to be 100 square root of 136. Right. 6 squared is 36. 10 squared is 100. Add them together. Take the square root. Your answer will be root of 136. But let's actually work it out. Do it the long way. The square root of x2 minus x1. Matt, what's x2 x1? Careful. 2 minus minus. Minus, let's get a plus there. 2 minus minus 4, 6. So 6 squared, remember that 6 from a while ago? And anybody, negative 5 and 5, subtract those together. Negative 10, remember that 10 from? Now we did 10. We didn't do negative 10. Doesn't matter. What about squared? 10 squared is 100, negative 10 squared is 100, same answer. So that'd be the square root of 36 plus 100, which is root of 136. Let's use our new stuff. Don't leave it as, that's exact. But let's see if we can remember how to break this down. We've got to find some number that will divide into 136 that we know the square root of. Everybody see, let's say, I know the square root of 4, I know the square root of 9, I know the square root of 16, I know the square root of 25, square root of 36, 49, 64, and so on and so forth. Does anybody take your calculator out and see if you can find one of these perfect roots that's located in root of 136? So here we go. Since the square root of 4 works, we divided 136 by 4. What did you get when you divided? 4 and 34. So we can split the square root of 136 into the square root of 4 times the square root of 34. mark out the square root of 4, because I know what it is. What is square root of 2? I put in a 2. 2 times the square root of 34, that's exact. Not only is that exact, that is simplified. If I want to approximate, squiggly, square root of 136, that's not quite 12, is it? It's 11.66. So approximate, exact. Another distance problem? Let's work this one the other way. Let me show you how to do this. To use a shortcut, first off, look at your x's and ask yourself, what's the distance? And I'm going to draw a little triangle here just to show you kind of what we're doing. What's the distance from my two x's? 1 to negative 3 is 4. What property did you just use? Is that not the segment division function? Because from 1 to negative 3, most of you, to do negative 3 to 1, here's your number line. Here's how I think of it. Here's negative 3, here's 1, here's a 0 in between there. From negative 3 to 0, that's a distance of 3. From 0 to 1, that's a distance of 1, so that's a distance of 4. How far is it from 2 to 0? Instead of using the distance formula, if you want to use the Pythagorean theorem, I like it. A squared plus b squared equals c squared. So 20 is c squared, so c is root 20. Perfect. Root 20 is the square root of 4 times the square root of 5. And get into this habit. Since it's the square root of 4 times the square root of 5, don't write down the square root of 4 times the square root of 5. The square root of 4 times the square root of 5. Square root of 4 is 2. Square root of 4 times the square root of 5 is 2 root 5. Any questions? The equation of a circle, we did this as a warm-up today. The equation of a circle with a center at negative 3, 5 and a radius of 4. All circles look like this. X squared plus y squared equals r squared. All circles are of that form. This circle has been moved. Let's see if you remember how to move circles. If I want to move my circle from 0, 0, I want to move it left 3. Hunter, do you remember what I put in for the x plus 3? The opposite of that. And Hunter, if I want to move my y value up 5, minus 5. Everybody go with the first part. X plus 3 squared, that's been moved left 3. Y minus 5 squared, that's been moved up 5. And a radius of 4 turns r squared into 6 squared. Transformation. It says the coordinates of the vertices of triangle RST are at negative 2, 3. Let's graph it. Negative 2, 3 at 4, 4. And at 2, negative 2. That's a triangle. Let me draw that. And what we want to do is it says triangle R prime, S prime, T prime. That's your triangle after it's been moved or whatever. Is the image of triangle RST after a rotation of 90 degrees. We want to rotate this triangle 90 degrees. And let's remind me of the rules. To rotate something 90 degrees, XY turns into, you'll have negative Y, negative Y. So we have to make the Y negative and we have to flip it. Which means that our first point, negative 2, 3, I'm going to list all 3 of them. Our first point, negative 2, 3, is going to turn into what? You're going to flip-flop them, make a Y negative. Negative 3, negative 3, don't make that negative 3, negative. So let's put that up. Negative 1, 2, 3, negative 3, negative 3. Our second point trace, 4, 4 is going to turn into negative 4, 4. So negative 1, 2, 3, 4, 1, 2, 3, 4 is there. And our last point, Briley, is going to turn into negative 2, negative 2, negative 3, negative 2. So left 2, down 2. I missed something. That's supposed to be, oh, positive 2, so yeah. Okay, good one. Flip them, make the y, that's 2. Make the y negative, flip them to 2, so right 2 up. There's my new triangle. That's been rotated 90 degrees about the origin. Connect the dots. So what used to be, you can check it like this. What used to be here is now here. Y'all see that right angle? What used to be here is now, let's see, what used to be at negative 2, 3 is now at negative 3. It's now at negative, I'll put that wrong. Just really rewrite it. That's what we're talking about. Negative 3. Negative 4, 4. What used to be at negative 3, negative 2, positive 3 is now at negative 3, negative 2. Those two are right angles to each other. Yeah. And the third division. You spun at 90 degrees. Counterclockwise. Moving on. Point A is located at 4, negative 7. The point is reflected in the x-axis. That means it's reflected across the x-axis. Somebody look at those and tell me what their transformation is. XY turns into x negative 1. So therefore, Jagger 4, negative 7 will turn into 4 positive 7. That's all you have to do. That's all your transformation. Now, this is not how we wrote it. But let me, just in case you're taking a standardized test and it's written like this, this is what it is. R, y-axis, that R simply stands for reflection. And this tells you where to reflect it. We're going to reflect it across the y-axis. Okay? So if you run up on something that says after this transformation, don't let it throw you off. It's just another way of writing the same thing. If we want to reflect something across the y-axis, xy turns into negative xy. So 2, negative 3 turns into negative 2, negative 3. No, that's it. Don't let that throw you off. Don't let that. Another one. Here's my transformation. Xy is going to turn into x minus 5, y minus 1. Does anybody know what this is going to do? Move it left 5 and down. So negative 1, 4, 2, 4, and 2, 0. Turns into, do these three for me, Riley, Carly, and Alex. Let me think about what is that? Riley, Carly, Alex. Riley, you got the first one. It's right here. Minus 5 and minus 1. It's a translation. Negative 6 and 3. Take your x, take away 5. Take your y, take away 1. Okay. Carly, what's your negative 3, 3. Take 5 away, take 1 away. And Alex, and you can graph that. I'm not going to, but you got a triangle, and that triangle is simply moving from 5 and down. Okay, so we'll graph that. Chapter 3. Let's do a few chapter 3. So you got about 8 minutes, and then we'll stop with that. The inverse. The need to remember what inverse, converse, and contrapositive is. One word. When you see inverse, what are we going to do? Not. Not. I think so. Say that. The prefix in actually means not. So anytime you're finding the inverse, we're doing the not of the statement. The statement says, and this is an if-then statement, it's a conditional statement. If two triangles are not similar, their corresponding angles are not congruent. Now we've got a knot there. We're knotting a knot. Anybody want to take a stab at that? The knot of if two triangles are not similar. What's the knot of that? If two triangles are similar, then they're corresponding. Similar, then their corresponding angles are their corresponding angles are says what is the converse of the statement if Bob does his homework and George does candy? When we do inverse, we not. When we do converse, we what? Flip them. Move them. Flip them to it. So now leave the if and then stuff. If starts, if is on the front and then is on the back. So if what? So if George gets candy, then Bob did his homework. See if you remember this. If a conditional statement, if the original statement is true, will the converse always be true? No. Will the inverse always be true? No, but the contrapositive will always be true. Converse and inverse might be, they don't have to be. Now, if an original statement and its converse is true, it's called a biconditional. If it's true front ways and back ways, that's a biconditional. But a contrapositive will always be true, and that's what we're doing next. What is the contrapositive of the statement? And I'm going to write this as a conditional like this. If I'm tall, then I'm going to bump my head. If I'm tall, then I'll bump my head. The contrapositive of that, those of you don't have to do it. We got to combine the converse and the inverse with this contrapositive. If I don't bump my head, then I'm good. If I don't bump my head, then I am not tall. Flip them and not. Can't really see these. What we're doing with these is we have the law of syllogism. And we have the law of just half. The law of syllogism and the law of attachment. And let's talk about which is an example of which. The first one says if an animal is a red wolf, then its scientific name is Canis rufus. If an animal is named Canis rufus, then it is endangered. What can we gather from that? If an animal is a red wolf, then it's endangered. What law is that? Syllogism. If A implies B, and then B turns right around and implies something else, then the original implies the last. If there is lightning, then it is not safe to be out in the open. If there is lightning, then it is not safe to be in the open. Marla sees lightning from the soccer field. What can we conclude? It's not safe to be out in the open. Right? That is the law of attachment. If we know something implies something, if we know A implies B, and we know that A is true, then we know that B is true as well. That's the law of attachment. If Galileo High School wins the championship, then the school will celebrate. Galileo High School wins the championship. What are they going to do? Celebrate. That's attachment. We know the first, it applies the second, and the last one is probably going to be syllogism again. If the stereo is on, then the volume is loud. If the volume is loud, the neighbors will complain. So therefore, if the stereo is on, the neighbors will complain. In the diagram below, let's talk about parallel lines. In the diagram below, line P intersects line L and line N. The measure of angle 1 is 7x. The measure of angle 2 is 5x plus 30. before we talk about whether they're congruent or whether they're supplementary, because they all are. If you got two angles when you're dealing with parallel lines and transversals, those angles are either going to be congruent or they're going to be supplementary. Let's name these angles. Let's remind you of what corresponding angles are: alternate interior, alternate exterior, same side interior, same side exterior. These two angles are what? On opposite sides. So alternate interior. Alternate interior, anybody, alternate interior angles are equal. 7x will have to equal 5x plus 30. Here's your list. Alternate interior equal. Alternate exterior equal. Corresponding equal. The only two that are supplementary are same side interior and same side exterior. So here's my equation. I move my x's to this side, I now have 2x. I divide by 2 and I get x is 15. It says then what when x equals what, that would be 15. But let's go on further. Let's actually plug it back in and make sure we're right. If x is 15, 7 times 15 is 105. 5 times 15 plus 30 also 105. Knowing those two, we now know all of them. This would be 105, this would be 105, this would be 75, this would be 75, this would be 75, this would be 75. Okay, we know all of them. Another? And this will be our last one. In the figure below, what is the measure of MKJ? MKJ, which would be this angle right. You can see the green there, 58 degrees, 98 degrees. What's going to be the relation? Is there a relation between 98 and 90 in another mark? Because these two lines, this line and this line are not parallel. Now they are, let me take it back. They are same side interior angles for those two lines, yes. But since those two lines are parallel, can we say they're supplementary? No. But I can say that this angle will be supplementary to 58. If you got parallel lines, which here DE and AB are parallel, if you have parallel lines, the same side interior angle would be supplementary. So this is 58, this would be 122 degrees. And you could go in further, this angle, if this is 98, that would make that 82 because those two angles would be supplementary. And you actually know every angle. You can do 82 and 82. Linear pair, that would be 98 and 82. This would be 98 as well. These are 98. These are both 82. These are both 122. These are both 58. Same thing here. You know the measure of all 6.